James here from Northwest HVAC in Spokane, Washington. I'd like to say thanks again for the 1,000 subs, and I appreciate each and every one of you guys for helping me get to that milestone. This is a much anticipated update to the oral exam video that covers all the changes that we made and all the kind of weird new different things that we do. And there's only a few small changes, so I'm going to go ahead and leave up the old one so you guys can compare and contrast, and maybe I left something out of this one or something different I did on the first one. But this one is completely intended to match the revised oral exam that I just rewrote like a year ago. So I hope you guys enjoy it, and let me know in the comments if I left anything out. Not that I'm going to revise it, but at least we can discuss it in the comments. Also, thanks again for the 1,000 subs, and I hope this helps as many people as the previous oral exam video has. Thank you. First place we're going to hit is the meter area. So, questions that consist on this area, probably you're going to be asked what this is. That's a regulator. You might be asked about that vent, to identify it or locate it. Also might be asked if you can adjust that. The answer is no. That belongs to the gas company. Only they are allowed to legally adjust it. The other thing that could be asked is the pressure that comes out of it. What does it regulate down to? I know that's one of the ones I like to ask. So from the street, the pressure of the gas comes in at 55 psi. Then it gets regulated down here in this regulator down to 7 inches of water column. And then that 7 inches of water column then flows all the way through the meter and on into the building. Next, you'll probably be asked about these two valves. You got that A9 valve right there. And if you look, that's on the exit of the meter. So that is a valve that we are allowed to turn on and off, because as you can see, it's on the 7-inch side of the meter. So there's no risk of blowing up the meter or the regulator or doing any kind of damage. Then this valve down here, what the gas company calls the service valve, or I refer to as the riser valve because it's on the riser of the meter. That valve right there, you are not allowed to turn on. That one can be turned off in emergency, but we have to call the gas company to turn it back on, because this is the valve on the 55 psi side, and if you turn that on incorrectly, you're going to jam that 55 psi really hard onto this regulator, and you could damage the regulator, the meter, cause leaks, all kind of bad things can happen. So recap, regulator regulates down to 7-inch water column, and then that valve there you can turn on and off all you want. That valve there you can only turn off in emergency. Gas company has to turn it back on. Now the next thing that could come up is this, the index. I tell you guys, typically call it the index, the dial assembly, dials, dial face, something with the word dial in it. If you want to remember the fancy name, it's called an index. Some people just want to know what that's called. I particularly like to ask what it's for. And the reason it's on the meter is to keep track of gas usage, to monitor the flow of gas to the building, so essentially so the power company can get paid. Down here on the bottom left is our 1/4 foot dial, which we'll be talking about a little bit later. And on the bottom right is the 1 foot dial, the one closer to that red stuff right there. Then I think lastly on the meter part, they might ask you what's the pressure test for Spokane when you're air testing the pipe, and that would be 10 psi for 15 minutes as we've discussed in class. When you're dealing with the air test, we talked about 10 psi for 15 minutes. We're going to have a gauge like this, and this is going to be attached to the pipe that comes out the wall of the house. So it'd basically be like right here, stuck out of the wall, hooked onto that pipe somewhere that's poking out, not yet hooked to the meter. and you're going to pressurize that up to 10 psi and let it stand for 15 minutes. And then you can go ahead and detach this gauge, and then you can finish connecting the pipe where the gauge was hooked up into this A9 valve on this end. And then here in a second I'll show you the other end when we go to do the purge. Okay, so in addition to hooking up that meter end, connecting the pipe, then on this end of the pipe you're going to have a cap, because we can't pressure test the meter, we can't pressure test the unit. So we'd have a cap installed over here somewhere on the furnace end of the pipe, and then the hookup process is taking that gauge off and taking this cap off, and then you'll finish piping in all of this stuff up into the unit, or all of this stuff here that connects into that unit. Now I got a kind of wide angle shot. It's not the easiest to see here, but I'll zoom in on a couple of things when the time comes. But the purge process is basically, you want to turn on the A9 valve, and then you want to come to the indoor unit, and you can see that red gas cock down there. That's turned off right now, and that should be the starting position of that when you go to turn the A9 valve on. So not super important that you say that on the test, but good practice is have that red gas cock closed, then turn on the A9 valve, then you come inside here, you open up that red gas cock. It's not always red, just so you know. Sometimes it's blue or other colors. Then we want to come to this union here, or the end of this flex line that you installed after you did your air test, and we want to open that up. You want to physically take it apart and separate it just a little bit, and then you're going to wait for the gas to come. The way we know that you have gas, they will ask you for the test, is you can listen for the pitch change, because it's going to go higher pitch because of the specific gravity of natural gas. You can also smell for gas with your nose, or you can use a CGI, combustible gas indicator, which people refer to as just a sniffer. So to zoom in a little bit on that union, you can see that union right there. That's what you'll be taking apart to do your purge. And then or over here on this flex line, you can see where that yellow flex goes in right there into that T. You would break it loose right there with a couple of wrenches and purge the line out that way. Lastly, don't forget, once you know there's gas present, listen, smell, or using a CGI, you want to tighten that union or flex back down, and you will lose points on the test if you forget the whole close it back down when you're done purging part. Kind of a no-brainer, but they do want to hear you say it during the test. And then one more note that they'll probably ask you, because it's actually on my test sheet. If you're purging propane, is there any special considerations you should make when you're purging propane? And the answer is, you want to either purge it to the outdoors, or you want to have adequate ventilation in the area when you purge, because propane is heavier than air. And for the record, its pitch change is going to go lower because of its specific gravity instead of higher like natural gas. Checking for leaks. Now, be careful with this one, because there's two ways, and I always get, when I'm doing the oral exam, I always get people telling me the way I didn't ask for. So the one way is to do a spot check, which I'm going to get to in a second. But while I'm already set up here from the purging, we'll talk about soaping the pipe. So while you're waiting for your spot check, which again I'm going to go over in a second, you can go through and soap everything. Now, what all do you want to soap? The best answer for the test is everything that wasn't part of the pressure test. So earlier we talked about after your air test, you got to come and you got to hook up, you got to take the cap off and hook up all these pipes into the unit, and you got to put this flex on and hook all this pipe into the unit. And then outside over at the meter, when you take off your gauge, you got to finish piping in the meter end of the pipe. Now everything in between those 2 points has already been air tested. So you only have to soap those 2 ends that you finished connecting after you pass your air test. Hopefully that's clear enough for you. But the best answer is everything that wasn't part of the pressure test. So for spot checking, you want to go to the dial, and this is after you've purged the line and the gas is on. So we're checking for leaks here. So you want to look at this 1/4 foot dial, which is that bottom left one, and you want to mark where it's at, take a picture, do something, and then go ahead and go soap everything or wait around for a significant amount of time. They don't actually put a time amount on the test, so we'll say 10 to 15 minutes, and then come back, and if that 1/4 foot dial has not moved, then that's a spot check. So I might want to add, even though it seems like common sense, you want to make sure nothing is running. There's no pilots lit, so there's no gas actually flowing, but the gas is turned on. So this will be done right after you do your purge. And so the way I do is I come look at the 1/4 foot dial, mark it, go soap everything. That usually takes maybe 10 minutes, 15, depending on how much you have to soap. Assuming you don't have any bubbles, you come back, you look at the 1/4 foot dial again, and it will have not moved. So we want it to not move. If it moves, that indicates a leak. How to remember that for the test? Spot check. We want that dial to stay in the same spot and not move from that spot. Clocking the meter. First things first, make sure every unit in the building is off, including any pilots that might be burning. So nothing is calling for gas, everything is off. And power off to the unit that you want to clock. Start by hooking up your manometer first and foremost. A little bit later I will go through some manometer hookup locations, but take your manometer and connect it to the unit you want to clock. Then your next step is to turn on the unit, make it call for heat. So right now you just have the one unit running, and this 1 foot dial should start to rotate. Looking at the arrow here, it looks like it's going to be rotating counterclockwise. So they say you want to catch it on the upswing. So right now you can see it's about 6 o'clock. So anytime here between 6 and midnight on the rotation, you want to pick one of those tick marks and start, let's say maybe that one. Start your stopwatch, let it go around one time, and then stop your stopwatch at that same mark, and then you have actually clocked the meter. So you take that amount of time, and we're going to use that formula that we go over in class, 3600 divided by those amount of seconds from that 1 foot dial going around one time times 1,000. So 3600 divided by those seconds times 1,000, and that will tell you how many BTUs you're burning. And then you compare that to the label on the unit, and you'll just determine if you're underfired or overfired, and you can adjust accordingly. And that's why you have the manometer on there, so you can see how much you're adjusting. Now to break that formula down, 3600 is the amount of seconds in an hour. And if you look at this meter, it says cubic feet on it. CU feet right there. 3600 seconds in an hour. And then this 1 foot dial, every time it goes around once, you burn 1 cubic foot of gas. So what you're doing is you're dividing it, the amount of seconds in an hour by the amount of seconds it took to burn 1 cubic foot, and you're going to get cubic feet per hour. And unfortunately the furnace label is in BTUs per hour, not cubic feet per hour. Well, luckily here in Spokane we have about 1,000 BTUs per cubic foot. So the math is real easy. You just take that answer, cubic feet per hour, times it by the 1,000. It'll convert it to BTUs per hour, and then you can compare that to your label. If you live in other areas, you just have to times it by a different number, 1050 or 950 or whatever your BTUs per cubic foot is, and then you'll still be able to clock the meter and get the same results, and then we can turn it up or down from there. Remember, we want to be, we cannot be overfired. That's illegal. We're allowed to be underfired by 10%. For the test, though, if they ask you overfired or underfired, I would just say no. We don't want to be either. We want to just try to be right on. But they do give you that 10% leeway underfired, but you can never be overfired. Okay, I got to go handheld for this part. I have anti-shake on, but it could still be a little bit wobbly. I apologize. For this next question, we're going to ask you, what is the pressure in that pipe? And that would be your incoming pressure from the meter. So that's still your 7-inch of water column. And then we're going to ask, what would be the pressure in this pipe? And that is your manifold. So you can see it's after your gas valve. The 7-inch comes in here, it goes through the gas valve, then it goes into that manifold. That would be 2 to 4 inches of water column if you're one of those nerds that has to have the specific numbers. Or my favorite answer is the pressure in the manifold is going to be whatever it was when I got done clocking the furnace. I think that's a perfect answer, and then you don't have to remember any numbers. You clocked it earlier, and whatever it was when you got done clocking it, that's what it is. So we're going to look at some hookups and some adjustments. So first one, this one's kind of got the old school manometer hookup. You can see that there's that plug right there, and but that's on the inlet side. So that'd be your 7-inch plug. That you take your manometer adapter and you could plug it in there. However, that's not where you want to hook up your manometer for clocking the meter, getting any usable manifold pressures. That's just going to give you your 7-inch from the meter. Where the one you actually want is over here on the side, and it's that big Allen head plug right there. So you'll take that out, put your manometer adapter in there, attach the hose, and then you'll run the unit and you'll get a reading, clock it, adjust it, all that kind of crap. So now your adjustment on this guy is actually right there. We got this brass cap. You take that brass cap off, and underneath that brass cap will be a little plastic flathead screw. You'll adjust that. And if you remember, we discussed in class, since it's a regulator, it's opposite of a water valve, so you're going to turn it in to increase, out to decrease, clockwise or in to increase gas pressure, counterclockwise or out to decrease gas pressure. Now there's 4 styles of valves in this lab. That's the first one. I'm going to show you the other ones here in a second. Another style is this one Carrier likes to use. And so this one has this nub right here. See that nub? That is where you would put a manometer, but this one is on the inlet side, so that's your 7-inch side. But this one's got a small little Allen screw inside. That you'll loosen, and then you'll literally take your hose and put it over top of that nub. Come back out a little bit. So you'll take your hose and just put it over that nub. You wouldn't use your adapter. But this is not where you put your manometer. That's on the 7-inch side. You want to actually get on this nub up here that's over here by the adjustment. So loosen that Allen screw. You don't have to take it all the way out. And then you'll slide your hose over the top. You'll get your manometer reading that way. And then again, under that brass cap, there's a flathead screw. In to increase, out to decrease. Okay, let's look at a couple other styles. This one is a 2-stage, and they can take you to any unit in here, so you need to be prepared to identify this stuff. But let's start by talking about the adjustment. There's 2 of those brass things. You can see one says high, one says low. So since this is 2-stage, it's got 2 firing rates, high fire, low fire. And those are both adjustments. They're both in to increase. Just remember, on a 2-stage, you have to clock it twice. You have to run it on high fire and clock that in, and then you have to put it down to low fire, and you got to clock that in. And on the label it tells you the BTUs for both high and low fire. The manometer on this one should be, there it is, over here on the side. Where is it? Where's my finger at? Right there. Behind that red and white wire is that big Allen plug that we saw earlier. Right there. You'll take that out, put your adapter in there, and hook your hose to the adapter, run it, get your pressure. But this one's two-stage, so you got to adjust both of those regulators. And of course, they're both in to increase. Okay, last one here, at least for this lab, is this one's modulating. So you can see down there to the right, there's that white dot. It says nat gas next to it. And underneath that, there's a plus or minus. That white dot is just a little plastic cap that you can pop off with your thumb. For the gas test though, you just got to point at it, and it tells you which way to increase and decrease with the plus and minus, but again, right or in to increase and out to decrease. But it's under that little plastic cap there next to that nat gas sticker. As far as your manometer goes, it's not the easiest to see, but it's actually back here behind the manifold. Right there. There it is. Right there. It's hiding behind the manifold over here to the bottom right of where that adjustment is. Right there. Start up and shut down sequence. So at this point they want to know that you know the sequence of operations of a basic furnace on a call for heat, for both for startup and then at the end of the call for heat for shutdown. So we're going to start with the startup, which is the thermostat closes. That's a given. Then you remember we got the acronym IP if given for beers. I is inducer, P for pressure switch, I for igniter, G for gas valve, F for flame sensor, and B, beers for blower. IP if given 4 beers. So the inducer fan's going to come on, going to start spinning, and then that's going to force the pressure switches to close. They're going to detect vacuum that the inducer fan is pulling, and also in the vent system, making sure we have good clear vent and good adequate combustion airflow. So pressure switch will close, then the igniter will start to glow, and you'll see that down here. And then after a while, when the igniter heats up, then the gas valve will open and the flames will light, and then the flame sensor over here will detect that those flames lit. This white wire underneath here, right there. You're welcome for that finger. And then once the flame sensor detects that the flame is present, then the blower will come on. So IP if given 4 beers. And I'll run it through so you can see it. Hold on a second, I'll do a startup on this. You can see that that inducer fan came on. So it's currently pulled closed the pressure switch. Since this is that 2-stage one we talked about earlier, it's probably going to come on low fire, but you'll still get to see the sequence. Inducer fan came on, pressure switch got closed. Here in a second, there it is, you can see the glow coming from that igniter. And now the gas should come on and light. There's the click of the gas valve. Now the flames are on. The flame sensor has detected that the flames are lit. And after probably 90 or so seconds, then the blower will come on. IP if given 4 beers. And there's the sound of my blower. So next I'll show you the shutdown sequence. Flames go off. Then you notice that the inducer continues to run for a little bit. It's doing what we call a post-purge. You guys on the test could just say clearing all the junk out. You can actually see that it's slowing down now. It's stopped. But it did continue to run a little bit after the flame shut off. And now, lastly, that blower will eventually shut off. No need to film that whole process. That's usually about 2 minutes. But the acronym for that is Grandma is Boss. So the gas shuts off first, then the inducer shuts off, then the blower shuts off. Now they're going to ask you, why does the inducer keep running after the flames shut off? And I said it earlier, it does a post-purge. You guys could also say to clear the junk out. And then they'll ask you, why does that blower keep running after the flames are off? And the answer for that is to cool down the heat exchanger. So the scenario is like this. At the end of every cycle, the manufacturer wants this thing to be, the next time it runs, they want it to be as if it never ran in the first place. So at the end of every cycle, that inducer fan is going to clear all the junk out of the heat exchanger, and then the blower is going to cool off the heat exchanger, so that the next time this unit cycles on, in the middle of winter, that could be every 10 minutes. So the next time it cycles on, it's got a cool heat exchanger and a clear combustion chamber and vent, and it's ready to go brand new, like it never ran in the first place. Here in a second, we'll move on to some safeties. Next, we're going to point out the safeties. So I might do a little bit of zooming. Remember, I advise you guys, when you're doing this, to kind of make a serpentine through here. So just kind of start at the top, sort of work your way through, and come to those safeties as you get to them. And so we'll start up here on the top left, right up there. This guy here, we got 2 of them. That would be your pressure switches. Now you can't see the hose on these. The hose is actually back here, right there, plugged into the back of that unit, but it's there. So remember, always round with a hose. That's your pressure switches. Next thing, when we serpentine through here, we come to this guy on the vent. That is what we call a vent safety switch, or in the trade, a lot of times they call that a spill switch. So that's a temperature actuated switch. You can see this little slot right here. Right there. If the vent gets plugged or something and the gases start spilling, they're going to spill out of that little hole, and the heat of that will actually make this switch trip and cut off the flames. So that's a spill switch or vent safety switch. Now, not the easiest to see here, but back here behind this yellow hose, you can see your high limit. Back there on the firewall right there. That is a snap disc style high limit. But that, again, that's always on the firewall. So you got to look back there on that firewall underneath the vent, typically between the burners and the vent. You'll have your high limit, or yeah, I'm going to stick with that. Typically between the burners and the vent, even on a 90%er. So next thing we have when we serpentine down through here, we've talked about 3 things so far: the high limit, the spill switch. So next thing is down here on the burners. You can see those 2 red wires. They're going down to a limit switch that's actually down here in this burner box. There's one on each side. So if we go over here, you can see it's hard to see, but some red wires coming down right here too. There's another limit switch over there. These are your rollout switches. So if you remember, they're always on the burner box. And I'll zoom in on one later. I can show you the manual reset button. But what you're looking for is a switch that's down here on the burner box that has a manual reset button. It doesn't always have red wires running to it, but it will have that manual reset button. If we come up a little bit here in the burners, down there, right here, you got this 2-wire thing. That's your igniter. Then over here just to the right, you have this 1-wire thing, what I pointed at earlier, right there. And that would be your flame sensor. Now the way you tell those apart is, you can see how your manifold comes in, and from the gas valve over here, the manifold comes down and it curves and it goes that way. The igniter is always at the beginning of the manifold, and the flame sensor is always at the end of the manifold. So that's kind of how you can tell them apart. Also, the igniter has 2 wires, flame sensor has 1. So that's 5 items we've talked about now so far. Last item, because you can't see it, it's down there behind that metal panel. That would be your door switch. So when we zoom out a little bit, so we serpentine through here, we have pressure switch, spill switch or vent safety. We have the high limit back there on the firewall. We have your rollout switches down here on the side of the burner box. We have your flame sensor, and then we have your door switch. And as promised, I'd zoom in on some rollout switches. So here we have, right on the burner box like we discussed, there's one right there with 2 yellow wires, and there's one right here with 2 yellow wires. So they're always on the burner box, on top of it, around it, to the side, whatever. But we can see that that one has that little red and black reset button in the middle of it. Right there. So some of the vent safeties also have reset buttons, but you'll definitely have reset buttons on your rollout switches. The next question is about red tagging of the unit. This is where the major changes happen and why I'm making this new video. We no longer are sabotaging the units when we disable them on what we used to call the long-term shutdown. So the unit is unsafe, you've deemed it to be unsafe, it's got a cracked heat exchanger or something, and we're going to shut it down and red tag it. So no longer are we doing the sabotage thing. We're going to turn off gas in 2 places. So as we discussed in the oral exam video, the previous one, and also in class, that could be the gas cock on the side of the furnace, and it could also be this on-off switch here for the gas, or the blue knob, or whatever knob those gas valves have on them. That'll be your 2 places. And then you want to shut off power in 2 places. So that's typically turning off the switch on the side and turning off the breaker. And then you want to hang your red tag on the unit, properly filled out, and you want to notify 2 people. One's typically the customer, and the other one is kind of a CYA, cover your behind. And so you want to notify your boss, a coworker. You probably want to notify the gas company. That way it's not just your word against the customer. So for the red tag thing, we have a 2-2-2 rule. 2 power, 2 gas, 2 people. Delta T, what's that about? Well, usually when I'm doing the oral exam, that's my first question. What's delta T? Well, you're going to say it's the difference in temperature between the supply and the return. So my supply is this duct up here that kind of bends to the left, and then my return is, right now it's just that electronic air cleaner, but there'd typically be a duct hooked there, right? So my next question is, why do I care about delta T? Why does it matter? Well, the answer is, in some form or fashion, you're going to need to say that it is important because we need to make sure the machine is operating the way it's supposed to. The truth of the matter is, we want to make sure the machine has the correct airflow. So delta T is all about airflow. When we talk about adjusting delta T, many people make the mistake when I'm on the oral exam with them to tell me, hey, if it's too hot, I'm going to turn down the gas. Do not say that. We already clocked the meter. The gas is set where it needs to be. There is no turning up or down the gas from this point. In order to fix delta T, we adjust the airflow. So let's go back to the ducts now. My next question is, okay, you told me about delta T, you told me why it's important. I'll say, how do you know what proper delta T is supposed to be? And the answer is, it's on the label. So if we can zoom in there, back behind that manifold, you see that black and silver kind of placard there behind the gas valve. That is your label. Now this is an old unit from the, I believe, 1956 or 57. So it's actually before they started putting delta T on the label. So it's actually not on this label, but all units do have it on there now. And it actually says temp rise on the label. So let's zoom back out. So you answered the question now, how do I know what it's supposed to be? And the answer is, it's on the label. So now I'm going to say, all right, where are you going to put your probes when you're measuring delta T? We could put them anywhere, right? And you're going to say, no. We have to make sure up here on the supply, we want to be either 4 to 6 feet up, or we want to be around that bend to the left, out of line of sight of the heat exchanger. Or maybe the first register in the basement if it's pretty close. But what we do not want to be is down there on the bottom where my students put some holes. Actually, you can't see them from here. They're right there, one on each side. And that's not good. And so during the test, I'll actually ask, why don't we just use these cool little holes that are already right there? Why we got to drill a new hole? And you're going to say, because it's too hot there. Now, you want to sound extra smart, you could say, oh, that's because we're going to get radiant heat off of the heat exchanger, and we actually need to measure the air temp, not the heat exchanger temp. So we have to be 4 feet up, or 4 to 6 feet up, or around that bend, or grab the first register that's close by in the basement. And then as far as the return air goes, it doesn't matter where we put it down there. You could throw it in the filter cabinet. I've thrown them in the blower door before. Heck, you could even use the temperature off the thermostat in the living room. But so anywhere in the return, it doesn't matter. We're not worried about any radiant heat coming off the return air. So next, we got delta T covered and how to measure it. How do you find out what it's supposed to be? So the way I usually ask this question, because I'm looking for the same answer open-ended, is I will say that if you measure the delta T and you compare it to the label and it doesn't match the label, how do you fix it? That's a general answer. You're just going to say you adjust the airflow. Now, in the class, we talk about how you adjust the airflow, so I'm going to address that now. If it's too hot, meaning the delta T is too high, you're going to increase the airflow. And if it's too low, you're going to decrease the airflow. Now, a lot of guys that ask the oral exam, they want to hear stuff about fan speed, and that's fine. Here in a second, I'll zoom in on a furnace board. I'll kind of show you what we mean by adjusting the fan speed. But it's not the only way to adjust airflow. We can add returns and supplies. We can take some away. We can block or open up airflow. If it's a belt drive, we can change the belt pulley sizes, things like that. So it's not necessarily always about adjusting the fan speed. But keep in mind with these modern furnaces, they have multi-speed fans. The easiest way to adjust your airflow is by adjusting your fan speed. So the last bit of that would be, they ask you, if your delta T is too hot and you don't fix it, what could happen? And the answer to that is you could crack the heat exchanger. So as a kid, you probably took a piece of metal and you bent it back and forth a bunch of times until it got hot, and then eventually it broke. Well, that's what your heat exchanger does. It gets too hot, it swells too much, and then it contracts back down, and then it swells and contracts, it swells and contracts, and eventually it will crack a hole a crack actually in your heat exchanger. And then regarding, then the next question they could ask you is, if it's too cold and we don't fix it, too low of a delta T and we don't fix it, what could happen? And keep in mind, this is only going to occur on an 80% furnace, a category 1, with the metal vent here, because it's the only time it's going to be a problem. But the answer, if the delta T is too low, it's too cold, is you're going to create condensation in that vent. So if we have a sub 140 vent temp, then the vent gases hitting the ambient air will condense in that vent, and then since that vent is metal, as you can see for yourself, then it's going to rain down inside there, it's going to rust out the vent and the heat exchanger and everything else, and that'll be bad news. And of course, obviously on a category 4, 90%er, we're intentionally creating condensation, so that's not a problem. They tend to run lower delta T's anyway, but that should be the gist of the delta T. So let me then now zoom in on a board, and I'll kind of show you what the whole adjusting the fan speed thing is about. Okay, so we see the blower motor. You can kind of see that capacitor down there, right there. And to the right of that capacitor, you can see like red, blue, yellow. There's also a black and white wire that you can't see here. I'll show you. Red, blue, yellow, black, and white. Should be able to see those. Okay, each one of those, besides white, because white is neutral, is a motor speed. Typically red's the lowest speed and black is the highest speed. And depending on your manufacturer, Carrier actually does it backwards of everyone else. But blue and yellow are medium low and medium high. So when you look at the board here, and let's see if I can zoom in on that. Hopefully my lighting's okay in here. I don't have the best lighting, but I can zoom in on the board. Ah, you can see it. So on the left there, you can see cool and heat. Right here. You can see cool and heat. So one you can see is black and one is red. Typically cool is high speed, red is low speed. And then down underneath, it's kind of hard to see, but you can kind of see that blue is underneath that black relay where that red wire is. You can kind of see the blue and yellow both connect down here underneath to two terminals called spare. They're sometimes also called park or M1, M2. And basically all that is a deadhead terminal on the board that is there for you to put your extra speeds that you're not using so that they're not just dangling in the furnace trying to short on things, right? So right now we have high speed plugged into cool, low speed plugged into heat. If my delta T was too high and I needed to increase my fan speed, then I would just unplug that red wire from heat and I would plug a higher speed wire into heat, like the blue or the yellow, and then I'd put the red wire down on the spare terminal, and now it's running on medium low or medium high instead of low. And again, if the delta T was too low, I could go down to a lower fan speed. But that's the gist of adjusting your fan speed right there. It's just a matter of where we plug it in on the board. Typically high is always for cool, and then we'll have those other three speeds available for heat. And sometimes you'll also have a unit that has a fan, has cool, heat, and fan, and that's for if you want to run a constant fan just to circulate airflow around the house or whatever, then that'll typically be the lowest speed, and then the heat will be on a little bit higher speed, some of the medium speeds, and then cool will be the high speed. But in this case we just have the cool and heat, and to adjust the fan speed you'll just take off the heat and plug on a different speed onto the heat. I'm going to show you a schematic real quick. I don't know if it'll matter to some of you, but just a quick look at what's going on this board and those fan speeds. So here's our schematic. You can see our motor. We have a white wire, common. We have a black wire, got a yellow wire, and there's our blue wire right there. So you can see that, and there's our red wire. So you can see that this red wire comes up here, and on this drawing it's plugged onto spare. And then our blue wire, it comes up here, and it's actually the one that's plugged into heat. Then we have our black wire coming up to cool. And then we have our yellow wire actually goes to another spare. And there's an orange shown here that we don't have on our motor. That would go to our other spare. So we have these 3 spare terminals down here just to hold our extra motor leads. And then we have cool and heat. And then of course the white wire off of our motor, that is, it says right there, common. So you basically just have your cool speed, your heat speed, and then your 3 spare terminals down here where you just plug your extra wires that you're not using off the blower. And to change the speed, you'll just unplug heat, and you'll plug one of these other speeds into heat, and then the one that was on heat, you'll just put back down on the spare. All right, lastly, we have spillage. What is spillage and how do you check for it? Well, when you have a draft hood unit, and we always get the argument that, why does this need to be part of the oral exam? Most furnaces now are fan assist. They don't have draft hoods. However, many, in fact probably most water heaters and a lot of residential boilers still are using natural draft. So it's still an important part of the deal. Not to mention equipment that's still out there that is still surviving this natural draft. So what is spillage and how do we check for it? Well, spillage is vent gases. We can see this is a draft hood, and I'll come up a little bit. You can see that that's an 80% furnace with a metal vent, natural draft. So we have this draft hood, and spillage is vent gases coming back down and spilling out of the draft hood. How do you check for it? You take a match, lighter, maybe some tissue paper, some powder, something light that you're going to be able to see movement, and you'll put it in front of here, and you want to check edge to edge all the way across, not just in the middle. So while I'm answering this question, I always tell you guys just to put your hand here like you're holding a lighter. Just move it back and forth while you're saying, take a lighter, a match, a candle, something. And what we want is, we want to see that flame getting sucked in here, not blowing out. If it's blowing out, you have spillage. Keep in mind though, this unit right now would be spilling because cold air sinks, and you're going to get cold air dropping down that vent, spilling out of this draft hood. So it's imperative that you mention the unit needs to be up, running, and up to temp, and then you're going to check spillage. So with this unit running and up to temp, you put a match, a lighter, candle, something in front of here, back and forth across the draft hood, and you want to see if it gets sucked in or if it blows out. If it blows back out, that's spillage. We want it to go in. Now this draft hood is just an open hole. It goes all the way up to the vent. Any cold air or anything like that can just easily come right down here. So you got to make sure it's warmed up and up to temp and establishes a good natural draft. Then you check it edge to edge with your lighter, candle, match, whatever. Make sure it's pulling in, and if it's not pulling in, that is spillage. Next, they will ask you if it's been running for a while and it's up to temp and you're still getting spillage, what are some things that could cause spillage? Number one is lack of combustion air. So remember I said earlier that this is just an open hole up that vent. So if this is in a small room and it's struggling to get good air for combustion, then it's going to start sucking air down the vent. Essentially it's going to create a negative pressure in the room, and that's going to make air start coming down the vent, spilling out the draft hood. And we want that because even some dirty air getting fed to that flame is better than no air. No air would definitely lead to flame rollout, which could catch the furnace on fire and cause really bad problems. So number one, lack of combustion air. Number two is a plug in the vent. Obviously if the vent is plugged, it can't draft out, so it's going to want to spill out of that draft hood. And then number three is wind, bad weather. You're going to have wind blowing down the vent, blowing spillage out. There's nothing you can do about that. Those first two you can address, give it more air or fix that plug, right? And then the fourth one that some people will talk about sometimes, but not really important for the test, is improper venting. So if it doesn't have the right vent on it, or if it's too long or the wrong size or whatever, then you can have spillage. I typically don't talk about that one on the oral exam because we're assuming that that would have been caught during installation of this unit. But I guess if you're the installer and you're doing an initial startup on this unit, then you might want to consider improper venting. But the big three is lack of combustion air, a plug, or wind. And then of course you could sprinkle in that improper venting as well.